So in 4.5, we're going to be solving polynomial equations by factoring. So we're continuing with what we did in 4.4 with the factoring, but we're just going to take it one step further and solve. So it says you have used the zero product property to solve factorable quadratic equations. You can extend this technique to solve some higher degree polynomial equations. So these are going to be factoring examples like we did in 4.4. So how would I factor this first? Take out the GCF. What's my GCF? Perfect, 2x. All right, so I'm going to take out the 2x. When I take out the 2x, I'm left with x squared minus 6x plus 9. I divided everything by the 2 and the x. That's still equal to 0. Can I factor this anymore? How? So my two factors of 9 would be -3 and -3. So I need that 2x on the outside and x minus 3 and x minus 3. It could be, yeah. How would I solve for 0? How would I solve for x? Sorry. What do I do with that equal to 0 part now? So I have 3 parts here. So all 3 parts of this get set equal to 0. So 2x equals 0, x minus 3 equals 0, and x minus 3 is equal to 0. So now I just have 3 little equations here. How would I solve the first one? Divide 2 on both sides. Perfect. What's 0 divided by 2? So x is equal to 0 is one of my solutions. What do I do for the next one? Add 3 to both sides. So x is equal to 3. And then for the third one, it's the same. Add 3 to both sides. So x is equal to 3. You only have to write it once if it repeats. So you could say x is equal to 0 and 3. If you write it twice, no problem. That's not a big deal. But these would be our answers. So in this step, just like Sophia said, we could have written it as 2x times x minus 3 squared because there's 2 of them. So it could be written like this. When you work it out and set each piece equal to 0, you'll get the same answers. So you could do it either way. So you could either write it like this, and that would be factored all the way, or like this would be factored all the way. They're the same. Either way, doesn't matter. But writing it as the x minus 3 squared leads us into this page here. So it says because the factor of x minus 3 appears twice, so it's talking about the example on the last page, the root of x is equal to 3 has a multiplicity of 2. Multiplicity just means that there's multiple of them. It repeats. So we had 2 of the x is equal to 3's. So in example 1, the factor of x minus 3 appears more than once. This creates a repeated solution of x is equal to 3. Note that the graph of this related function touches the x-axis but does not cross the x-axis. So I'll pull up a graph of that equation in a second. At the repeated 0 of x is equal to 3. And it crosses at the x-axis at the 0 of x is equal to 0. So we can summarize that. It says when a factor is raised to an odd power, so when we only have one of them, it crosses the x-axis. If it's raised to an even power, so something like that x minus 3 squared, when I have 2 of the x is equal to 3, it touches the x-axis but does not cross. So when we have odd multiplicity, it crosses. When it's even multiplicity, so because I have 2 of them, and 2 is even, it touches. And it just touches but doesn't cross. So this is an example of the even, because we're talking about the exponent. All right, example 2, we have to find the zeros and then sketch the graph. So we're going to do both here. So finding the zeros, we just make it equal to 0. And we solve just like we did in the last one. What do you think I need to do first here? Take out the GCF. What's my GCF? Just 2? Let's take out a -2 because we like it when our leading coefficient is positive. So I'm going to take that -2 and put it on the outside. So now I'm left with x to the 4th power minus 8x squared plus 16. Now how can I factor this? I need 2 factors of 16 that add to -8, so -4, -4. So when I break that up, what goes into my parentheses? X squared minus 4 and x squared minus 4. And that -2 stays on the outside. Now can we factor this anymore? Why? How? They're both perfect squares. So this is the difference of squares and this is the difference of squares. So what does it factor into?
X minus 4 and then x plus 4.
4 breaks into what?
2.
2 and 2. So x minus 2 and x plus 2. And then the other one's the same thing. X minus 2 and x plus 2. Because the difference of squares factors into a plus and a minus. Bless you. All right, so when we solve this, what do I have to do next to solve? So we could write it as squared. So it could be written as x minus 2 squared and x plus 2 squared. But when we are solving it, we just set each piece equal to 0. So I can start with that -2 is equal to 0. Does -2 equal 0? No. So because there's no x here, it's not a solution. We can just cross it off. Then I want to set each one equal to 0. So x minus 2 equals 0. X plus 2 is equal to 0. X minus 2 is equal to 0. And x plus 2 is equal to 0. So x is equal to, how would I solve the first one? Add 2 to both sides, so x is equal to positive 2. Second one, I would subtract 2 on both sides, so x is equal to -2. X is equal to positive 2, and x is equal to -2. Yeah. So my 2 different solutions are here. 2 different solutions here are 2 and -2. What's my multiplicity at 2? How many 2's do I have? 2. So I have the multiplicity of 2, which 2 is even or odd? Even. So does that mean my graph goes through or touches and turns? Go back to the last slide. What does it say? It touches and turns. When the multiplicity is even, even means that it touches and turns. Now, how many -2's did I have? 2. So I have a multiplicity of 2, which is even or odd? Even. 2 is an even number. So when my multiplicity is even, do I touch and turn or go through? Touch and turn.
So if it was like x equals 3, then it'd be go through.
If another 0 was x is equal to 3, and I only had one of them, so we're talking about like how many of them we have.
So if there were like 2 zeros that, if there are 2 x's that equal 3, then it'd be go through.
If I had 2 zeros that equal 3, so let's say I had x is equal to 3, and x is equal to 3. How many 3's do I have? 2 of them, so that 2 would be even, and it would touch and turn. So it depends on the amount of them that you have. Then it would be odd, so then it would go through if you had 3 of them. So let's draw our graph. Now it just asks us to sketch the graph, so it doesn't have to be perfect. I'm not even going to put numbers on my y-axis. I just want to make sure I put the zeros here. So I need to put a point at 2 and a point at -2. Now I know at both of these points my graph is going to touch and turn, but there's also one more thing that I need to know. I need to know the end behavior of the graph. So that was what we did before break. The end behavior. So that's just the arrows where it rises and falls. We got to think way back before Christmas. So we're looking at the -2x to the 4th power. So what's the end behavior of my graph? Both arrows? So it's negative, so the right arrow we know goes down. And is 4 even or odd? Even. So do they go in the same direction or opposite directions? Same direction. So they go down and down. So at my 2 points, at the point farthest to the left and at the point farthest to the right, they go down and down. Bless you. Now let's start with -2. We'll start with the left one. At -2, what did we say? Does it touch and turn or go through? Touch and turn. So we're not going to cross the x-axis. We just touch it and we turn like that. Touch and turn. Now I'm going to make my way over to the other point. At 2, what do? Touch and turn. So I'm going to touch that point and turn. So my sketch of this graph looks like this. It's this kind of M shape. It doesn't go through the graph. It just touches and turns at those 2 points. So again, that's super important. You only touch the x-axis at the zeros. We will never ever cross at any other point other than the 2 zeros that you found, or however many zeros you find. So as a reminder, I'm going to do a couple examples on the side to remind ourselves of end behavior since it's been a while. So I would definitely write this down, especially if you don't remember going over this before Christmas. So end behavior. If the leading coefficient is positive, so let's say I had a positive 2x to the 3rd power. What would my arrows do here? So if it's positive, what's the right arrow going to do? The right arrow goes up. But if it's odd, what are they going to do? The left one goes in the opposite direction. So let's say I had a negative 2x to the 3rd power. What's my right arrow going to do? Right arrow goes down because it's negative, so the right one ends going down. So positive or negative always tells us about the right one. So positive or negative describes the right arrow. And my exponent is odd, so what's the left one going to do? The left one goes up. They go in opposite direction. So even or odd, even is the same direction. Odd is opposite. So let's say I had a positive 2x to the 4th power. What would my arrows do? They go up. They're going to go in the same direction because my exponent is even. and it's positive, so the right arrow is going to go up. Let's say I had negative 2x to the fourth power. What would my arrows do? They both go down. So let's start by finding the zeros, and then we'll go back to graphing. So I set it equal to 0, and I need to solve. What should I do first to solve? Greatest common factor. What's my greatest common factor? 3. So I'm going to divide everything by 3. So I can take out the 3. Now I'm left with x to the fourth power minus 2x squared plus 1. Careful, because 3 divided by 3 is 1. Now we need to factor this more. Do I have two factors of 1 that add to negative 2? Negative 1 and negative 1. So I have 3 times, what would go into my parentheses? Awesome. Since it's x to the fourth power, it has to break up into x squared and x squared. So x squared minus 1 and x squared minus 1 equals 0. Can I factor this anymore? What's special about x squared and 1? It is the difference of squares. So how would it factor? X plus 1 and x minus 1. And same with the other one, x plus 1 and x minus 1. Since we have 2 of them, it's 2 difference of squares. Now that I factored it all the way, what can I do next? Well, let's finish solving. Set them all equal to 0. So 3 equals 0, x plus 1 equals 0, x minus 1 equals 0, x plus 1 is equal to 0, x minus 1 equals 0. What do I do with that 3 is equal to 0? Cancel it out. There's no x there, and 3 does not equal 0, so it goes away. What about x plus 1 is equal to 0? Awesome. We subtract 1 on both sides, so x is equal to -1. With the other one, I would add 1 to both sides, so x is equal to +1. And we get -1 and +1. So my two zeros are x is equal to -1 and x is equal to +1. Now, how many -1s do I have? 2. So I have a multiplicity of 2.
So you don't put even.
Well, 2 is even. And even tells me that I go through the graph or touch and turn. Touch and turn. Now next, how many 1s do I have? So I have a multiplicity of 2. 2 is even. So since it's even, am I going to go through or touch and turn? Touch and turn. So on my graph, I can put a point at -1 and +1. But I need to know my end behavior. So let's go back to the original graph. Starting with my leading coefficient. That tells me which arrow does. The right arrow, and it goes up because it's positive. So the end behavior, the right arrow is going to go up. 4, is it even or odd? Even. So are they going to go in the same direction or opposite directions? Same. So the left arrow goes up also. So from my point farthest to the left, I have an arrow that goes up. From the point farthest to the right, I have an arrow that goes up. All right, so let's go to our points. At -1, we said we touch and turn. So I don't go through this point, I just touch and turn. And I make my way over to the other point. What about at +1? Do I go through or touch and turn? Touch and turn. So I touch the point and bounce right back off of it. So this would be my graph. So that W shape. So number 4. We can start with the end behavior if we wanted to. What's the end behavior of my graph going to be? How did we know the right one was going to go up? Because it's positive, so the right one goes up. And then the exponent is, the exponent's odd. And odd means that they go in opposite directions, so the left one's going to go down. So we'll save that for the end. We'll come back to it for when we graph. But let's factor now. So I can take out my GCF, which is an x. Always start with the GCF, bless you, if you have one. What am I left with when I take out an x? X squared plus x minus 6. This is still equal to 0. Now let's see. Do I have two factors of -6 that add to 1? 3 and -2. Perfect. So in my parentheses, I have x plus 3 and x minus 2. And then I can't forget about the GCF that I took out. And it is still equal to 0. After we factor, now we need to solve. So how would I solve? Set each piece equal to 0. So x is equal to 0. X plus 3 is equal to 0. And x minus 2 is equal to 0. Bless you. So x is equal to 0 is already solved. We're good there. How would I solve the second one?
-3.
Subtract 3 on both sides. So x is equal to -3. And then the third one?
+2.
Add 2. So x is equal to positive 2. Just be super duper careful with your signs when solving. They're little tiny equations, but signs are important. All right, so let's look at our solutions that we got. How many zeros do I have as an answer? 1. So I would have the multiplicity of what? Of 1, which is even or odd? Odd. And odd means that we touch and turn or go through? Through. Now let's look at the next one, negative 3. How many negative 3's do I have? 1. So I have a multiplicity of 1. Is 1 even or odd? Odd. If I have a multiplicity of an odd, do I touch and turn or go through? Go through. And then lastly, let's look at 2. How many 2's do I have? 1. So my multiplicity is 1, because I only have 1, 2. Is 1 even or odd? Odd. So be careful. Even though the number is even, we're talking about how many of them we have. 1, I have 1 of them, so 1 is an odd number. If my multiplicity is odd, do I touch and turn or go through? Go through. So let's graph. I'm going to draw my graph. I need a point at 0, negative 3, and 2. So we already found the end behavior. What's my left arrow going to do? Go down. So I'm out of the point farthest to the left. I put an arrow that goes down. What does the right arrow do? Up. So at my point farthest to the right, I go up. Now at negative 3, did we say we touch and turn or go through? Through. So I go through that point. Make my way over to the other point at 0. Do I touch and turn or go through? I go through again. So I go through that point. And then at 2, do I touch and turn or go through? I go through. So my graph looks like this. Good question. So these are just sketches of our graph. So like if we were to put this into a graphing calculator, it probably wouldn't look exactly like this. One of these may be higher than the other one. But since it's just sketching, it's just the direction that's important. So like the shape and direction. That's why we don't put numbers on the y-axis, because it doesn't matter.
So now we're just doing it like that.
Mm-hmm.